Hello, good people. Welcome to the first video of Unit 10. Unit 10, which involves infinite series and how we can use infinite series to describe what we call transcendental functions. Now, before we get deeper into that part of it, we do want to spend a couple of videos here reminding ourselves what a sequence is, what a series is, what's the difference between the two, and what it means for them to converge and diverge. So this first set of videos is targeted towards that, I guess, basic understanding of what is a sequence, what is a series, how do I know whether either of those converge or diverge. So going back to your previous math classes, at some point you talked about sequences, and you talked about sequences that were given in terms of an explicit formula. Now, you don't need to know this, but this is what we call an explicit formula. And the reason is because if I want to know what a sequence is or what the sequence list is, all I need to do is use this formula, because if I want to find the first term, that means n equals 1. So I'm going to substitute 1 into this formula. And if I substitute 1 into the formula, this would be negative 2 to the 1 power, which is negative 2, plus 1, that would be negative 1. The answer is the term in that position. And if I want to find the second term, well, then n would equal 2, and I would substitute 2 into the formula. Negative 2 to the second power, that's positive 4, plus 1 is 5, positive 5. That's the second term. And so I can create a whole list of values, which we call the terms in this sequence, by just substituting the position of the term into the explicit formula. So the nice thing about having the explicit formula is that we can build as many of the terms in the sequence as we want by just using the formula and substituting the position number into the formula. So if I wanted to find this represents the 10th term in the sequence, and all I would need to do is substitute 10 into the formula, and then whatever I get, that would be the actual 10th term. So this is the symbol that tells me we're looking for the 10th term. I'm using the formula to figure out the value of the 10th term, and this explicit formula is what helps me do that. So just as a reminder, a sequence is a collection of terms that are in a one-to-one correspondence with positive integers. That's a fancy way of saying sequence is a list, an ordered list of terms where the term position matters, right? So this is N1, this is N2, this is N3, this is N4, this is N5. So when they say there's a one-to-one correspondence with the positive integers, that means negative 2 belongs as the first term, and 4 is the second term, and negative 26 over 6 is the third term. Now, we weren't given the formula to figure these terms out, but we're just looking at them as a sequence of numbers that are in a specific position, and therefore that makes this a sequence that I can then analyze and determine whether it converges or diverges. Before we get into that idea and into series, there are two types of sequences we want to make sure we understand. First, there's a monotonic sequence. Monotonic, just like when you talk monotone and it's never changing and your voice is always sounding at the same pitch. A monotonic sequence is a sequence that never decreases or never increases. So the numbers could be getting smaller or maybe even repeating, but they're never going back up. So if I were to graph a monotonic sequence, and I'll do this this way, I could, for example, in the first one, it says the first term is less than or equal to the second term, which is less than or equal to the third term, which is less than or equal to the fourth term, and so on. So for the first term, maybe my value is there. For the second term, oh, this one's bigger. For the third term, oh, that one's bigger. For the fourth term, oh, maybe it's the same. For the fifth term, oh, that's bigger. But the idea is that it's never decreasing, right? Or vice versa. If a sub 1, the first term, is greater than or equal to the second one, which is greater than or equal to the third one, which is greater than or equal to the fourth one, then it's backwards, right? It's never increasing, but it's either going down or leveling off in the same y, the same term value before it continues on its pattern. So monotonic just means it never decreases and it never increases. We also have what are called bounded sequences. And bounded sequences mean that there is a value that an upper bounded sequence means that there's a value that the points never get higher than. And if there's a lower bound, well, then we know that there's a value that the sequence never gets below that value. And if it's just completely bounded, that means it has an upper bound and a lower bound, right? So an example of that would be maybe a sequence that starts at one, and then it goes to one half, and then it goes to one third, and then it goes to one fourth, and then it goes to one fifth, and then it goes to one sixth. So I can see that this sequence is bounded above. This is a bounded sequence. It's bounded above by one, like that's the highest value. That's the upper bound. And it's bounded below, let me choose a better color here. And it's bounded below by zero. That's the lower bound. So therefore, this is a bounded sequence. It is quote unquote trapped between a highest output value and a lowest output value, right? So bounded sequences are going to be helpful because their behavior is predictable and we can work with that. Okay, so all of this has been about sequences. So we're going to make a slight change and we're going to talk about series. Now, a series is just a sum. And I'm going to correct something here. This is a sigma notation, right? And the sigma notation is the math symbol for summation, where we're adding things. We're going to add terms of a sequence starting from the first term, that's what this little number is down here, to infinity. So in reality, I'm going to have to correct this. I don't think this should be here because if it's going to infinity, that means this sequence just keeps on going forever. So you might ask yourself, well, how can I find the sum of an infinite number of terms? And we're going to find that depending on what kind of terms I'm adding, sometimes I can add an infinite number of terms and get an answer. But sometimes I can add an infinite number of terms and the answer just keeps getting, the sum just keeps getting bigger and bigger and bigger and bigger, and it never approaches a specific value. And so that's one of the keys that we're going to be investigating when we do Unit 10 is we're going to be asking ourselves these questions of, let's see if I can bring it up here. Is it this one? Or is it this one? I think it's one of these. I think it's one of these, but I don't know which one it is. Here it is. So these are the big ideas of Unit 10. When we talk about series, we're going to be asking ourselves, does the series converge or does it diverge? And we're going to start the process of figuring that out today with this set of videos. We're also going to be asking, if it does converge, what value does the series converge to? And then other questions we're going to ask ourselves is, if we approximate the series, how close are we to the actual value? So even if we can't add an infinite number of terms, can we approximate it? What is the error if I approximate it? And then if I have a series, it might only converge between specific values, right? It might be bounded somehow. And then the last thing is, can we manipulate series to create related series? And that's going to be kind of the ending of Unit 10 of putting everything together. But we start with the very basic, the first two questions are, does the series converge or does it diverge? And if it does converge, what does it converge to? The first question is sometimes easier, a lot easier to answer than the second. Even when we know that a series converges, sometimes it's a little bit hard to figure out what it converges to. But we'll talk about that here in a little bit. All right. So this is the full series, right? Infinite series, it goes on forever. However, if I add the first couple of terms in the series, if I just add the first n terms, then this is what we call a partial sum. So a partial sum is adding the first 3 terms, the first 5 terms, the first 100 terms, the first n terms. That's the partial sum. An infinite series is adding all of the terms. And when I say all, I mean an infinite number of terms, which technically we can't do because we're doing infinity, right? How do we add an infinite number of terms? We run out of time, we get old, we die. But we're going to find ways to do that. without dying, without getting old. We'll be able to do it within the confines of this course. So just to make sure we understand, and this is the end of this first video, there's a difference between a sub n, and this is the expression that gives the nth term of a sequence, versus s sub n, and s sub n gives the nth partial sum, which is the sum of the first n terms. And so we're going to look at an example to tell the difference between these two. It's very important that we separate the idea of a sequence with a series, and a series which involves a partial sum. So little a, little b, little c sub n is the nth term of the sequence. Capital S sub n is the sum of the first n terms of the sequence. So when I look at this example here, I have the sequence 2, 4, 6, 8, 10, and it goes in that pattern. Can we find a sub 4, and can we find s sub 4? Well, a sub 4 is the fourth term, 1, 2, 3, 4. N equals 4, that would be the eighth, that would be 8 as the fourth term. So a sub 4 is just 8, because that's the fourth, the value, the number, the term in the fourth position. That's different than S sub n. S sub n, or S sub 4, is asking for the fourth partial sum. That means we're going to add the first four numbers of that sequence. So the fourth partial sum, capital S sub 4, is adding the first, second, third, and fourth, and stopping there. I think I can add 4 and 6, that's 10, and 2 and 8, that's 10, so total that's 20. So my S sub n, which is the fourth partial sum, is 20. A sub 4, which is the fourth term, is 8. We're going to come back in the next video. We're going to talk about how we're going to approach infinite series, and then what it means for it to converge and for it to diverge.